Hi everyone. In this video, I'll walk you through a short crash course on feature engineering for time series forecasting. We'll take a real data set of minimum temperatures in Melbourne, and I'll show you how to turn raw time series data into a supervised learning platform that machine learning model like random forest can understand. The key idea is that machine learning models don't know what yesterday means, so we'll have to encode time using features like lag and rolling statistics. So let's go ahead with doing that. I will first basically do our imports. First I import the usual libraries pandas, NumPy for data handling, matplotlib for plotting, and Zscaler for machine learning model and evaluation. Then I load the daily minimum temperatures data set from an online CSV. It contains one column. Um, the minimum temperature in Melbourne for each day from 1981 to 1990. Here you can see the first few rows, and if I plot it, you can see a nice daily time series with visible ups and downs over the years. Next, from time series to supervised data. Before jumping into the code, it is important to understand classical models like ARIMA work directly on time series, but most machine learning models just share rows of features and a target. They have no built-in sense of time. So we convert the series into a supervised form. Like all the inputs, we need to change a bit. To do that, we'll create lag features to give the model memory of recent values and rolling feature to summarize recent trends and volatility. So this is what I was explaining. Now we have created lag features for the model. Now we will create three lag features. So you can see over here. So here I create three new columns, lag 1, lag 2, and lag 3, which represent the temperature 1, 2, and 3 days ago. The intuition is simple. If today's temperature is related to the last few days, then these lags contain predictive information. After this step, each row doesn't have to have today's temperature. It also has a short history attached to it. So next, I'll go over the rolling statistics for trend and volatility. So I compute a 7-day rolling mean, a 7-day rolling standard deviation, and a 30-day rolling mean. The rolling mean acts like a smoothened trend. It tells the model whether we are in a generally warmer or a cooler period. The rolling standard deviation measures short-term volatility, how stable or unstable the temperatures have been lately. These features compress a chunk of recent history into meaningful numbers. This is what I was talking about. Next, we clean, train, and test spread the data. Because lags and rolling features look backwards in time, the first few numbers will always be null. So I drop those columns, and then we can see the supervised data set over here, which looks like this. So next, I'll go about creating a naive baseline where tomorrow, which is equal to today, values where I get values like tomorrow is equal to today. Before using any fancy model, I define a simple baseline. Here the naive forecast is predict tomorrow's temperature as today's temperature. In code, that is just using lag 1 as the prediction. I compute the mean absolute error or MAE for this naive model. This gives us the benchmark. If our machine learning model doesn't beat this, it is not worth the extra complexity. This is what I just compared over here. Now based on this, I'm training a random forest model. So you can see here, just a second. Yes, here you can see that a random for now I train a random forest regressor using all of the engineered features, lags, and rolling statistics. After fitting the model on the training data, I predict on the test set and compute MAE again. If you compare the MAE of the random forest to the naive baseline, you should see that the random forest achieves a lower error, meaning that the feature engineering successfully captured useful temporal patterns. After this, I am plotting predictions versus the actual things which you have got. So we can see over here. To visually inspect the performance, I plot the actual temperatures and the random forest predictions. The blue line is the true temperature and the orange line is the forecast. You can see that the model tracks general shape of the series quite well. It follows the ups and downs, even if it is not perfect at every single point. This plot together with the MA gives us a good sense of how well our pipeline is working. So to be one step ahead for the future forecast, finally I show one simple one step ahead forecast. I take the most recent row I try the most recent row, which contains the latest lags and rolling features, drop the target column and feed it to the trained random forest. The output is the model's prediction for the next day's minimum temperature, which we can see over here. This is the one which I was talking about. So I'll go about references for theory and best practices are referred to forecasting principles and practice by Hindman and Athanasopoulos, Jason Athanasopoulos, Jason